Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting concept in the subject analog and digital communication. We're going to see about AM receivers. In this video, we will see what is AM receiver, what is the function characteristics of AM receiver, and you will see what are the different types of AM receiver. Before going in depth about AM receiver, we know what is meant by a receiver. What is the function of a receiver, right? I would recommend you people to go and watch my previous videos so that you can understand the basics concepts about the communication. We have started with what is communication, what is transmitter, what is receiver, what are the different types of AM transmitters, right? So please go and watch previous videos and come back to this video so that you can clearly understand this particular video, right? So what is meant by receiver, first of all, before going in depth about AM receiver, right? We know that in any communication, in all of communication, a signal which is transmitted at the transmitting side, right, it will be received at the receiving side so that the original message signal will be recovered, right? Which means in the transmitting side, say for example, we do modulation. What is modulation? In order to transfer the original message signal for a very longer distance, we perform modulation where we combine message signal and the carrier signal. And that signal will be transmitted to a very longer distance. At the receiving side, the receiver, what it will do is it will receive this particular signal, right? And then it will demodulate this particular signal. What is demodulation? It will separate the message and carrier and it will recover the original message signal. So this is the operation of any particular receiver. It will receive the signal and it will recover the original message signal, right? So we can call radio receiver as an electronic device which picks up any RF signal and recover the original baseband signal, right? And we know this overall process of communication where a original message signal, right, that will be transformed to another form. It can be an electrical signal, right? And that electrical signal will be processed and then it will be transmitted along with the electromagnetic wave, right? And the receiver will receive this electromagnetic wave and converts this electrical signal to the original form of the signal using the receiver transducer, right? And then that original signal will be here, right? The original audio signal will be here. This is the common working of the RF communication, right? We have already seen all those things separately, right? And now you understand what is the working of a receiver, right? And when we say a receiver, it not only detects the original message, it does series of operation. It does series of functions. What are those functions? You can see this is the function of a receiver where it performs interception, selection, RF amplification, detection, audio amplification and reproduction. These are the important functions of the receiver, right? So what is interception? Interception is receiving the particular signal, right? That is capturing the transmitted signal. That is called as interception. By using the antenna, it will receive the signal, right? And that process is called as interception. And what is selection? We know that there will be a mixture of frequencies, right? You'll a lot of frequency components you'll be receiving, right? And in that, it has to select the correct frequency component, correct carrier signal, correct carrier components, right? And that is called as selection. It has to select the desired signal and it has to reject all other signal, right? That process is called as selection, right? And after selection, after selecting the desired signal, then it has to amplify that particular signal. It will be amplified and then we can use class C tuned amplifiers to amplify to boost up that particular signal and then it will be sent to the detector where detection is a very important process of receiver where it recovers the original message signal, right? That original message signal will be a low frequency signal and that signal will be amplified by using series of amplifier, right? Where you can do audio amplification and then it will be reproduced. Reproduced in the sense it will reproduce the original message signal. This is the functions of a receiver. We will see one by one. As I said, interception is performed by antenna. It will receive the particular signal, right? It will receive the incoming wave from various transmitted station And this radio waves contains electrical energy in the form of electromagnetic wave, as I said before, right? And these electromagnetic waves will be intercepted by the antenna, and a single antenna intercepts radio waves of all carrier frequencies, right? It can receive signal of all carrier frequency, all the frequency components, right? But we need only a particular frequency, particular carrier frequency, right? So now it performs selection operation. What is the selection operation? The ability of a receiver to select the desired signal, desired carrier signal, right? And reject the all other signal. That process is called as selection. And it can be done by using a tank circuit, right? Where the tank circuit, you'll have a resonant frequency. It will be tuned to a particular frequency, and that particular frequency signal will be only selected. And this can be done with the use of variable capacitor or inductor, right? And even though large number of modulated carriers from various transmitters is intercepted, only one frequency components will get selected, right? That process is called as selection. And then RF amplification, as I said, the desired signal, after selecting the particular signal, it will be amplified by using class C tuned amplifier. And we have to amplify the signal so that the detector will not have any problem in detecting the original message signal, right? So that the linear detector can operate in the linear region. So the original signal will be amplified by using a class C tuned amplifier. And increasing the carrier voltage also suppresses the effect of noise, right? And detection, as I said before, detection is the process where the original message signal will be recovered by the receiver, right? Say for example, if you have modulated wave, from that modulated carrier, it will remove the original message signal. And after removing the original message signal, after recovering the original message signal, that particular signal will be further amplified, where we can use RC coupled amplifier and followed by a class B amplifier. Depending upon the application, we can use n number of stages to increase the amplification, right? And class we reproduce the original signal, that is the electrical signal will be converted into the desired physical message signal, right? And in any commercial broadcast receiver, the output of the audio amplifier is fed to the speaker that produces the sound according to the input audio signal, right? The same explanation what I have given, right? That is how the message is transmitted, and then how it is transmitted in the form of electromagnetic wave along with the electromagnetic wave. First, initially it converts the original message into an electrical signal, and that electrical signal will be transmitted along with the electromagnetic signal, and once again that electrical signal will be converted back to the physical message signal, right? And this is the complete operation of a receiver, right? Now, when it comes to receiver, this is the functions of the receiver. You have to know what is the characteristics of the receiver. How can we say a receiver is a good receiver, right? It performs well, right? It depends upon these three parameters, that is selectivity, sensitivity, and fidelity. So what is selectivity? Selectivity is very important. As I said, it will select a particular carrier frequency, a particular desired signal frequency, correct? Right. So selectivity is the ability of the receiver to select the correct desired frequency component, right? It will select the correct carrier component. That is called as selectivity, which is even though it receives more carrier components, it will select only the desired carrier component and reject all other signals. So the ability of the receiver to select the desired signal and rejecting all other signals is called as selectivity, right? And this selectivity can be done by using tuned circuit, by tuning the particular circuit to a particular frequency and selecting that particular frequency alone, right? And that tuning, right, the selectivity depends upon the Q factor of that particular tuned circuit, right? If the Q factor is high, then selectivity will be high. And what is sensitivity? Sensitivity is the ability of the receiver to pick up the weak signal, right? That is called as sensitivity, right? So even though it has select the desired signal, in that desired signal, there will be some weaker signals, right? That signal will be identified by the receiver, right? So the ability of the receiver to identify that weakest signal is called as sensitivity. And what is fidelity? Fidelity is the ability of the receiver to exactly replicate the original message signal. That is called as fidelity. If you can able to reproduce the original message signal exactly, the exact replica of the original message signal, then that is called as fidelity. Right? Now we'll see what is selectivity. As I said, it's ability to select the correct carrier frequency, right? Even though there is two adjacent carrier frequency, the receiver has to select the correct carrier frequency and reject all other frequencies, right? And selectivity depends upon the sharpness of the resonance curve of the tuned circuit, where you can see we have two resonance curves, right? Whereas this curve, right, curve 1 performs better than this particular curve because how sharper the resonance curve, the better selectivity, right? And if it is better selectivity, then it can able to reject all other undesired signal, right? And the sharpness of this curve depends upon the Q factor, where Q factor is equal to frequency, carrier frequency divided by bandwidth. And if Q factor increases, then selectivity also increases, right? This is the important characteristic of a receiver. And what is sensitivity? The ability of the receiver to detect the weakest possible signal, right? Say for example, you have a receiver with good sensitivity and a receiver with poor sensitivity, and if you're going to give same input signal, a receiver with good sensitivity will be able to produce more output when compared to the other receiver. That's because it has the ability to detect even the weakest possible signal, right? And the sensitivity of the receiver is decided by the gain of the amplifying stages, whatever amplifying stages which you have used, right? That determines the sensitivity of the receiver, right? And fidelity of a receiver is ability to reproduce the exact replica of the transmitted signal, right? The amplifier must pass the high bandwidth signal to amplify the frequencies of outermost sidebands, whereas for better selectivity, we need narrow bandwidth, right? For amplifier, we need wide bandwidth, whereas for better selectivity, we need narrow bandwidth, right? So this is the important characteristics of AM receiver, right? And what we have seen so far is we have seen what is a receiver, what is the AM receiver, what are the different characteristics and functions of AM receiver. Now we'll see the different types of AM receiver, where we have three important types of AM receiver. One is tuned radio receiver. We have a lot of AM receivers, but these three is very important AM receivers. Tuned radio receivers, right? Super heterodyne receiver and double super heterodyne receiver, right? We will see all this working in the subsequent videos, but as of now you understand what is meant by tuned radio receiver, right? We have already seen the functions of the receiver, and you have to understand here, any particular RF communication, right? The signal processing has to be done at the lower frequencies, right? Whereas the signal transmission has to be done at the higher frequency, right? To minimize the cost, because processing the high frequency signal, right? It increases the cost, whereas transmitting the low frequency signal, it increases the cost, right? So while processing the signal at the receiver side, most of the receiver except tuned radio frequency receiver, right, all of the receivers will convert the original signal into an intermediate signal, right, to a lower frequency, and then it will detect that particular original signal from that particular signal, right? Whereas tuned radio frequency receiver works in a different principle, where there is no mixing of signal. It will directly receive the original signal, it will select the desired signal, and that particular signal will be sent to the detector, and the original message signal will be recovered and will be amplified and it will be used, right? So that is the overall working of TRF and super heterodyne receiver, where in super heterodyne receiver we will mix the signal and convert it to IF signal, and from the intermediate frequency signal we will obtain the original message signal. Whereas here the desired signal will be tuned and you will select only the desired signal, and from that desired signal, desired carrier frequency, we will obtain the original message signal, right? We will see in-depth working of tuned radio receiver and super heterodyne receiver in subsequent videos, right? So far today what we have seen is, we have seen the working of AM receiver. We have seen the function characteristics of AM receiver, and we have seen the types of AM receiver. I believe this video will be useful for you. Thank you, my dear students.